Let's demolish your comfortable illusion about the universe's edge. Imagine you're standing at what you think is the boundary of the universe. Stop. That's not a boundary. That's a failure of imagination. The concept of an edge is a classical trap, a remnant of Newtonian thinking that dissolves under quantum scrutiny. What you perceive as a limit is nothing more than a placeholder for your incomplete understanding. Classical physics hands you a map with "here be dragons" scrawled at the margins. Quantum mechanics erases those margins entirely. Consider quantum fields. They don't respect boundaries. They permeate what you naively call empty space, a term that's already wrong. There's no such thing as empty. Quantum fields are everywhere, fluctuating, interacting, generating potential at every microscopic point. The vacuum isn't a void, it's a seething quantum landscape of potential interactions. Take the cosmic microwave background radiation. Most physicists show you this and say, well, look, here's the oldest light we can see. But that's not the end. That's just the beginning of our ignorance. This radiation isn't a boundary. It's a snapshot of quantum information processing at a specific moment of cosmic evolution. Quantum mechanics reveals that edge is a linguistic convenience, not a physical reality. When you say edge of the universe, you're revealing more about the limitations of human perception than about cosmic structure. We're trapped in three-dimensional thinking, trying to map an infinitely complex quantum realm onto our infantile classical intuitions. Most people stop at what sounds good. You stayed for what's true. Subscribe, like this video, and share your perspective in the comments. Let's keep thinking clearly together. Consider entanglement. Two particles can be separated by what seems like infinite distance, yet they instantaneously communicate. Where's the edge there? Our classical notion of spatial separation collapses. Information doesn't care about your comfortable geometric assumptions. Black holes provide another devastating critique of boundary thinking. Their event horizons aren't edges. They're information processing surfaces. Every bit of information that crosses that threshold is conserved, transformed, but never destroyed. The horizon isn't a wall. It's a quantum membrane of radical information transformation. Emergent spacetime further demolishes your boundary assumptions. Space itself might not be fundamental. It could be an approximation, a large-scale statistical emergence from more fundamental quantum interactions. Like temperature emerging from molecular motion, space might be a collective behavior of quantum information dynamics. The holographic principle, one of the most profound insights in modern physics, suggests that all the information contained in a volume of space can be encoded on its boundary surface. But boundary here doesn't mean what you think. It's not a physical border. It's an information theoretic projection, a quantum computational surface that encodes the entire volumetric complexity. Relativity already showed us that space and time are fluid, interconnected. Quantum mechanics goes further. There might be emergent constructs, not fundamental entities. Your intuitive sense of a universe with clear edges is a comfortable fiction, a story we tell ourselves to manage our cognitive limitations. Every time you imagine an edge, you're falling into a classical trap. Quantum reality is about probabilities, potentials, information flows. It doesn't care about your need for neat boundaries. The universe isn't a container. It's a vast, interconnected, quantum computational process. The moment you think you understand the universe's limits, you've already misunderstood. Quantum mechanics is a perpetual invitation to radical uncertainty, to dismantling our most cherished assumptions about reality's structure. Your classical intuition is a liability. Embrace the quantum perspective. No edges, only potential, only information, only transformation. If this challenged how you see reality, follow the channel and tell me what you think. Forget everything you think you know about information. Your classical understanding is a crude approximation, a kindergarten sketch of a quantum masterpiece. Information isn't just data. It's the fundamental currency of reality, not metaphorically, literally. Every particle, every interaction, every quantum state is an information processing event. The universe isn't a machine that contains information. It is an information machine. Let's deconstruct this ruthlessly. The no-hiding theorem in quantum mechanics reveals something profound. Information cannot be destroyed or completely concealed. When you think something is lost, it's merely transformed, redistributed, encoded in quantum correlations that extend far beyond your naive perception. I consider decoherence the quantum mechanism that makes quantum superpositions collapse into classical measurements. It's not a mysterious process. It's an information transfer. When a quantum system interacts with its environment, information doesn't vanish. It spreads, entangles, gets redistributed across a complex quantum network. Black hole thermodynamics demolishes the classical notion of information loss. Stephen Hawking's initial claim that information disappears into a black hole? Wrong. Completely wrong. The black hole's event horizon is an information processing surface. Every bit that falls in leaves a quantum trace, a holographic imprint on the horizon's quantum fabric. Entropy isn't disorder. It's information complexity. When entropy increases, it's not chaos. It's a more sophisticated information arrangement. Your intuition about randomness is a failure to recognize the deeper quantum information dynamics at play. Quantum entanglement reveals information's non-local nature. Two particles can be light years apart, yet instantaneously correlated. This isn't magic, this is fundamental information mechanics. Distance becomes irrelevant. Correlation becomes the fundamental reality. The quantum vacuum isn't empty. It's a seething quantum information landscape. Virtual particles constantly emerge and annihilate, a perpetual quantum computation happening at scales too small for your classical detectors. Every vacuum fluctuation is an information transaction, a momentary quantum negotiation of potential states. Gauge symmetries, those deep mathematical structures underlying fundamental interactions, are information transformation rules. They're not just mathematical abstractions. They're the operating system of quantum reality. Particles aren't things. They're information exchange events. Information conservation is a more fundamental law than energy conservation. Energy can change form. Information can be transformed, but its fundamental quantum signature remains inviolate. Every interaction preserves quantum information, even when it appears to vanish from your limited classical perspective. Quantum fields are information transmission networks. Particles are excitations. Information ripples in these fields. When a particle moves, it's not a classical trajectory. It's an information propagation, a quantum probability wave exploring multiple potential paths simultaneously. The holographic principle takes this further. All the information in a three-dimensional volume can be encoded on its two-dimensional boundary, not as a metaphor, as a fundamental quantum computational mechanism. Your sense of volumetric space is an emergent information projection. Quantum error correction, a concept from quantum information theory, shows how quantum systems maintain coherence. It's not just a technical detail, it's a fundamental insight into how quantum information preserves its integrity across complex interactions. Time itself might be an emergent property of information dynamics, not a fundamental dimension, but a statistical consequence of quantum information processing. Your linear, classical sense of time is a massive oversimplification of a much more complex quantum information flow. Every measurement is an information exchange. Every interaction is an information transformation. Reality isn't something that happens. Reality is an ongoing quantum information computation, with probabilities replacing your comforting classical certainties. Your classical intuition is a straitjacket. Quantum information is the key to unlocking a more profound understanding of reality. If this reshaped your understanding of information, follow the channel and share your quantum revelation. Causality. You think you understand it, you're wrong. Your classical notion of cause and effect is a kindergarten model that shatters under quantum scrutiny. Causality isn't a linear arrow. It's a complex quantum network of potentials, probabilistic interactions that laugh at your simplistic understanding of temporal sequence. See, quantum mechanics doesn't just modify causality, it reconstructs it from fundamental information principles. Every interaction is a negotiation of potential states, not a deterministic chain of events. The universe doesn't follow your neat little timeline. It explores multiple potential causal pathways simultaneously. The delayed choice quantum eraser experiment obliterates classical causality. Imagine a photon that seems to decide its past behavior based on a measurement made after its supposed trajectory. This isn't a magic trick. This is fundamental quantum mechanics revealing that your understanding of cause and effect is infantile. Consider quantum tunneling. A particle passes through an energy barrier that, according to classical physics, it shouldn't be able to penetrate. This isn't a violation of physics. It's a demonstration that probability is more fundamental than your classical deterministic assumptions. The particle doesn't break the rules. The rules are probabilistic quantum information exchanges that your classical intuition can't comprehend. Time reversal symmetry in quantum mechanics is not a mathematical curiosity. It's a profound revelation that the fundamental laws of physics don't distinguish between forward and backward temporal directions at the quantum scale. Your arrow of time is an emergent statistical phenomenon, not a fundamental constraint. Quantum entanglement demolishes local causality. Two entangled particles can instantaneously correlate their states across arbitrary distances. This isn't faster than a light communication. Deeper form of information correlation that exists prior to your classical notions of space and time. The uncertainty principle isn't just a measurement limitation, it's a fundamental statement about the nature of quantum information. Position and momentum can't be simultaneously precisely defined because they're complementary information channels. Your desire for precise simultaneous measurement reveals more about your classical cognitive limitations than about quantum reality. Relativity already showed that time is relative, malleable. Quantum mechanics goes further. Time might be entirely emergent, well, not a fundamental dimension, but a statistical consequence of quantum information processing. Your sense of temporal flow is a massive oversimplification of a much more complex quantum computational mechanism. Quantum superposition means that particles exist in multiple states simultaneously until measured. This isn't a quirk. This is the fundamental nature of quantum reality. Your classical intuition demands that things be in one state or another. Quantum mechanics reveals that potentiality is more fundamental than definitive states. Decoherence explains how quantum superpositions collapse into classical measurements. But it's not a mysterious process. It's an information transfer. When a quantum system interacts with its environment, information doesn't vanish. It spreads, entangles, gets redistributed across a complex quantum network. The quantum Zeno effect reveals how continuous observation can freeze quantum states. Paradoxically, watching a quantum system can prevent it from changing. This isn't a contradiction. It's a demonstration that observation is an information exchange that fundamentally alters quantum systems. Gauge symmetries are the deep information transformation rules underlying fundamental interactions. Particles aren't things. They're information exchange events governed by these profound mathematical structures. Your classical notion of discrete, unchanging particles is a crude approximation of a much more dynamic quantum reality. Quantum field theory reveals that particles are excitations in quantum fields. Information ripples propagating through a complex quantum landscape. When a particle moves, it's not a classical trajectory. It's an information propagation, a quantum probability wave exploring multiple potential paths simultaneously. Causality limits aren't boundaries. They're information processing constraints. The speed of light isn't a speed limit. It's an information transmission protocol for quantum computational processes that extend far beyond your classical understanding. Your classical intuition is a cognitive prison. Quantum causality is a radical probabilistic information dance that renders your deterministic worldview obsolete. If this transformed your understanding of causality, follow the channel and challenge your quantum assumptions. Emergence, not a buzzword, a fundamental reconstruction of reality. Everything you think you understand about the nature of reality is an emergent approximation, a statistical shadow of deeper quantum processes. Your classical world isn't fundamental. It's a large-scale illusion generated by quantum information dynamics. Space-time itself is likely emergent, not a container, not a stage, but a collective behavior arising from more fundamental quantum interactions. Like temperature emerging from molecular motion, space and time might be statistical phenomena arising from quantum information processing. The holographic principle is your gateway to understanding emergence. Imagine all the information in a three-dimensional volume encoded on its two-dimensional boundary. This isn't a metaphor. It's a fundamental quantum computational mechanism. Your sense of volumetric space is an information projection, a quantum computational result. Quantum fields are the ultimate emergence engine. Particles aren't fundamental objects. They're excitations, information ripples propagating through quantum field landscapes. When you see a particle, you're witnessing a momentary quantum information exchange, not a discrete object. Complexity emerges from simple quantum rules. Look at cellular automata, simple computational models where complex patterns arise from minimal interaction rules. The universe operates similarly. Profound complexity emerges from fundamental quantum information exchange principles that are elegantly simple. Consider how consciousness might be an emergent phenomenon, not a mystical property, but a computational result of complex quantum information processing. Your sense of self isn't a fixed entity. It's a continuous quantum information flow, constantly reconstructing itself through interactions. Entropy isn't disorder. It's information complexity. When entropy increases, it's not chaos. It's a more sophisticated information arrangement. Emergence is the process by which simple rules generate complex behaviors. Your intuition about randomness is a failure to recognize deeper quantum information dynamics. Black hole horizons demonstrate emergence perfectly. They're not boundaries. They're information processing surfaces where quantum computational mechanisms transform and redistribute information. The event horizon isn't a wall. It's a quantum membrane of radical information transformation. Quantum decoherence shows how classical behavior emerges from quantum interactions. When a quantum system interacts with its environment, quantum superpositions collapse into apparently classical measurements. This isn't a mysterious process. It's an information transfer that generates the illusion of classical reality. Gauge symmetries reveal how fundamental interactions emerge. These aren't just mathematical abstractions. They're the operating system of quantum reality. Fundamental forces emerge from deep information transformation rules that extend far beyond your classical understanding. The vacuum isn't empty. It's a quantum information landscape of constant potential. Virtual particles continuously emerge and annihilate. A perpetual quantum computation happening at scales too small for classical detection. Every vacuum fluctuation is an information transaction. Relativity and quantum mechanics suggest that space and time are emergent properties. Not fundamental dimensions, but statistical consequences of more fundamental quantum information dynamics. So your sense of continuous smooth space-time is a massive oversimplification. Quantum error correction mechanisms show how complex systems maintain coherence. It's not just a technical detail. It's a fundamental insight into how quantum systems generate stable, apparently classical behaviors from fundamentally probabilistic interactions. Information conservation is more fundamental than energy conservation. Energy can change form, but quantum information maintains its fundamental signature. Every interaction preserves and transforms information, generating the complex emergent reality you experience. The universe isn't a machine. It's an ongoing quantum information computation. Emergence is the mechanism by which quantum potentials generate the complex, apparently classical world you inhabit. Your classical intuition is a crude approximation of a far more profound quantum reality. Reality isn't something that happens. Reality is an ongoing quantum information emergence, yes, with probabilities replacing your comforting classical certainties. Your classical intuition is a cognitive limitation. Emergence is the key to understanding the quantum nature of reality. If this expanded your understanding of reality's fundamental nature, follow the channel and share your quantum revelation.